Hello and welcome to Bowler CBT Labs. My name is Matt Bowler, and in this video we will be taking a look at Dynamic ARP Inspection configured on a Cisco Catalyst 3550 switch. Dynamic ARP Inspection can be deployed and implemented using a couple different methods, one of which is through the use of the DHCP snooping feature. If you have this enabled already, the Dynamic ARP Inspection will essentially ride on top of that database and perform its inspections based on the bindings within the DHCP snooping database and the bindings there on the switch itself. The other method is to create a static access list on the switch, and that is an ARP access list where you will bind a IP address and MAC address, and then the inspection will be configured globally on the switch. There are two options that you have for the specific interfaces themselves, one of which is to trust and the other is to not trust an interface. As you can imagine, our host facing ports would be considered untrusted, as that is where the attacks will be originating from in the case that someone is attempting to perform an ARP spoof attack, and our switch-to-switch communication is where the interfaces will be trusted. In this particular setup we do have a 3550, and on this computer, the 192.168.0.101, I have two network cards on that particular computer. They are both connected to the switch, and although this main connection here, the 101, is not a switch, I will configure that to be a trusted interface in the hopes of not losing connection to that computer. In the case that there's an emergency and I do lose connection, I can always finagle the configuration on the switch to get it to work. But that's kind of a test lab specific note there. It's nothing critical that has to do with the actual implementation and the testing of the Dynamic ARP Inspection itself. So we may lose connectivity here periodically to that particular box through this lab, but it will not impact what we are doing with the inspection itself. So that's kind of a side note there. We will be configuring a static ARP access list on the switch, but before we do that, I'd like to show you some of the actual configurations here that are going to be involved with the ARP inspection deployment itself. The first command here that we would like to take a look at is the IP ARP Inspection command, and we have four options here. We have up top here the filter keyword, which is where we will apply the actual ARP ACL or ACL, the access list, that will be used for filtering on different VLANs, or in this case we will be doing it on VLAN 1, since the two network cards that connect to the switch, ports Fast Ethernet 0.14 and 0.16, those are both configured as VLAN 1 for their access port there. The next command is log buffer, so this will allow us to tune the logging that is generated by the IP ARP inspection. And we'll see some messages pop up here saying that the connections have been denied or the IP ARPs are invalid. We can also configure validation, which will validate, show the, we can do this based on destination MAC address, we can do it based on IP address, and source MAC address. And what this does is compares the MAC addresses in the packet, the header there. We can inspect the destination MAC, the IP address, and the source MAC. We can compare that to our ACL or the DHCP snooping database that is running, if in fact we do have DHCP snooping configured on the switch itself. The last option here is the VLAN keyword, and this is where we will enable or disable the inspection for the specific VLANs. To get started, we will configure ARP inspection for VLAN 1, and that will enable the inspection for VLAN 1. Before we apply a filter, we will need to actually configure the access list, and we do so by entering ARP access list. We will call this ARP_filter. Go ahead and hit enter. And the structure here for the access list is very similar to that for an IP access list. So if I hit the question mark for our help, we can see that we have permit and deny statements. If I slide this screen over here to the right a little bit, I've got a DHCP server running here in the background, and that's serving out the interfaces on our server back there. We can see the 101 and the 102 addresses. So I would like to configure entries in this access list for each of those, because I know that those are the legitimate MAC addresses and the IPs that they should be associated with. I'm going to permit IP and we're seeing invalid ARPs already there. Okay, the Fast Ethernet 016 interface is one that is trusted, so we will do IP ARP inspection and trust that interface. So it's already telling us that it doesn't like what it's seeing there. Moving on with the actual access list configuration, ARP filter. We will permit IP for a host of 192.168.0.101 with the MAC address of 00. We'll say this is a host so that we know what the MAC address will be here. There's no sort of mask that we need to apply to this MAC address, since it is a single MAC address. And we will say this is the 001 Delta dot 0 Foxtrot Foxtrot 8 dot 516 Delta, and log on match. We will also permit the IP of 192.168.0.102 with the MAC address of 0024 8 Charlie Delta 3 Delta 737 and log. And then we will deny IP any MAC any log. Now that we have the ARP access list configured, we can apply this using the IP ARP inspection filter, and then enter in the name of the access list. We're not done yet. We still need to apply that to a VLAN, and this will be applied to VLAN 1. So now let's back out here, do show IP ARP inspection. We can take a look at the interface status. Take a look at Fast Ethernet 016. We see that that one is trusted. 14 is untrusted, and we can see that it is rate limited to 15 packets per second. I can also look at the IP ARP inspection log. There are no entries currently. I can look at it based on VLAN. We see that this is the ACL that we have configured. It is active, and the configuration is enabled, so this is for VLAN 1. And I can also take a look at the IP ARP inspection show IP ARP inspection statistics, and we can see some lingering statistics there. So if we want to clear those out, I can just do an IP ARP inspection statistics and do it again and see that we have a clean slate there. Now, in order to actually generate some denies here, let's hop on over to our secondary NIC here, which has the 102 IP, see down here, and we will go into the properties of this, select configure, and we'll take a look at the advanced tab, and under here we see that there's an option for the network address. Just assign a random MAC address that obviously doesn't match the MAC address that is configured or burned into the card itself. So upon changing this, we should see some denies come across here showing that there are invalid ARPs being retrieved on the fast Ethernet 014, and that those should be denied and dropped. So it's probably going to, we'll delete that entry for it in the DHCP server. Okay, so we've got these messages coming across here showing that there were invalid ARPs, requests that is, received on fast Ethernet 014 VLAN 1. And we can see that the source MAC address that's coming across and the IP address. So these are going to continue to file in. If I take a look at these, oh, I cleared the statistics on accident there. If I take a look at the statistics, you should see these begin to populate. I'll do a ping on that IP address, and I'm probably going to see, yep, here we see a deny here for each individual ping request that's sent. And if I show the statistics again, we can see that there have been 6 drops, and these are dropped due to the ACL. If they were being denied due to the DHCP snooping database, we would see there as well that they are being denied through the DHCP method. And we would have a different message down here. It would say that there was a DHCP snooping deny, invalid ARPs. The actual message itself here would be pretty much the same, but the reason here, the match, why it's being denied, would reflect that of the DHCP snooping database. So we're going to continue to get these invalid ARPs, and what I would like to do here is actually show you that the permits will increment as well once I get this configured. So temporarily, since we are in the lab environment here, I can go into that interface, the fast Ethernet 014, and enter the IP ARP inspection trust. So we'll trust that interface and say, hey, you know what, we're getting denies here, but I do trust that interface, so it's not necessary to perform those checks anymore. And we can see immediately our connection has been restored over here to our remote desktop session. And now what I will do is go back into the advanced configuration for that interface, set the MAC address back to that of the one that is configured, do a no IP ARP trust, and do a show IP ARP inspection statistics. And now let's ping. Could be having some issues here just because of the IP addresses that are configured on that machine. And the fact that I need to delete that entry so that it can grab a new address, and I'm going to clear the IP ARP entry for on our ARP table for that address. Now this guy should be able to grab a new IP address from the DHCP server without too much of an issue. We'll go ahead and disable it and then re-enable, and we can see there that it is grabbing an address now. You can see here that while it temporarily it wasn't able to get an address from the DHCP server, so it was getting that 169.254 address. It was seeing that as invalid because it was also checking based on the MAC address, and it was saying, hey, I know this MAC address. So if I do a show ARP access list, we see that that MAC address is associated with this IP, and therefore it was being denied. So if I show the statistics here, we can see that the permits came across because they were matching this access list for the IP address and the MAC address. Try and ping it one more time, but I don't think it's going to work. Oh, it actually did. Okay, well that's a good sign. Now, for the DHCP snooping portion of things, if I don't have it currently configured on the switch, but if I did want to, I could enter the IP DHCP snooping. I'd configure it globally, and then I would also set it up to snoop on a specific VLAN. And I can verify the MAC addresses. There is a DHCP snooping video that goes along with this series, the CCNP Security SECURE series. So if we have DHCP snooping configured, and I take a look at the bindings, there are currently no bindings because it hasn't learned. We configured the snooping after these IP addresses were actually assigned. So if I were to go over here and release this IP, and actually disable that interface and re-enable it, once it grabs that new IP address, we should see here that it is grabbing that and adding it to the database. And there we show that the snooping database has grabbed the IP address and MAC address for that Fast Ethernet 014 interface. And really, this will be the ideal situation in a production environment if you have several hosts. I mean, you could potentially have several hundred hosts out there where your computers are grabbing their IP address through DHCP because that's convenient and easy, and it's deployed almost everywhere. You are basically creating a dynamic access list, and the inspection is done based upon this table. So instead of having to go through and manually configure those ARP access lists, you have this DHCP snooping database which is available, and then the ARP inspection is done based upon this database. So it's a lot easier. The configuration wise, you don't have to go through and do a configuration on each switch for each MAC address that's assigned to an IP address, or associated with an IP address on that switch for all those workstations, because you can imagine that that could get out of hand very quickly. But in the lab environment, it is part of one of the ways that you can deploy Dynamic ARP Inspection. So it's good to take a look at all the aspects and do the configurations here, because there's not a whole lot to it, and really it's a simple technology that can save you a lot of headaches. So I would like to thank you for taking a look at this video. I hope you've been able to get some useful information out of it, and I hope you go back to your lab and do some of these same configurations, do a little bit of tweaking, and really make it your own to further the knowledge, solidify the knowledge base that you have with these different technologies, and begin to see how the Cisco solution really is it's scalable, and it's one that you can continue to build upon time after time as you gain more and more knowledge. I hope you will continue to take a look at these videos and join us down the line as we get into some of the more advanced Cisco technologies. Thank you.